Okay, let's unpack this. We are standing here in 2025,
Mm.
right in the thick of a massive technological revolution.
Absolutely.
And, nowhere is that pressure cooker more intense than in the heart of global trade. I mean,
Mhm.
maritime transport is dealing with just immense growth.
Staggering volumes. We're moving so much containerized trade.
But the ports themselves, they are fundamentally territorially constrained. They're fixed nodes. They
Right.
can't just keep building out new infrastructure
Yeah.
forever to meet what seems like exponential demand.
And that is the defining constraint of the whole modern maritime system. The imperative now isn't really expansion, it's optimization.
Amper efficiency.
Exactly. That desperate need for hyper-efficiency and completely fluid operations is the core driver behind this rapid move from, traditional ports to what we now call smart ports.
And these aren't just concepts on a whiteboard anymore, are they?
Oh no, this is industrial reality. They are leveraging a core stack of technologies. Think artificial intelligence, the Internet of Things, digital twins, and of course, blockchain.
So our mission today, for you, is to go way beyond the buzzwords. This deep dive is going to dissect the two most critical technological pillars that are making this happen.
The first being simulation.
Right, the pillar of simulation and foresight, which is mostly driven by digital twins. And then the second pillar is trust and accountability, which is delivered by blockchain.
And we really need to analyze how those two work together.
Yes, there's synergy. But maybe more importantly, we have to get into the vital real-world trade-offs. The friction between this relentless push for AI-driven efficiency and the unavoidable challenges that pop up in cybersecurity and labor.
Okay, so to set the baseline for everyone, what exactly defines a smart port in 2025?
What are we really talking about?
We're talking about autonomy. These are highly automated facilities designed to operate 24/7 with minimal or in some cases no direct human intervention at all.
Wow.
They integrate these cutting-edge digital tools to significantly boost efficiency, transparency, and also, critically, sustainability across the entire operational spectrum.
And if autonomy is the definition, then AI. AI is the engine.
Has to be.
Our sources really emphasize a crucial point here, that AI stands out as a general-purpose technology, or GPT.
And when you hear that phrase, you really need to think big.
It's not just another piece of software.
No, not at all. Think in the same historical league as, like, the steam engine or electricity.
That's a huge claim. Why?
Well, why is it a GPT? Because its function is scalable and it's modular across every single process in the port. Electricity didn't just power one machine. It powered every machine in every industry.
Right.
In the same way, AI isn't just optimizing one little schedule. It's revolutionizing planning, vision, scheduling, risk mitigation, the whole canvas. It's allowing machines to perceive, understand, and learn from and respond to their environment completely on their own.
So we're really moving past simple software optimization and into systems that are genuinely cognitive.
Precisely. And the heavy lifting here is being done by subfields like machine learning, ML, and deep learning, DL. These ML algorithms, they ingest and analyze just massive amounts of historical port data. I mean, we're talking about years of data points on weather patterns, specific equipment maintenance logs, even the observed skill levels of individual human operators, and of course, real-time sensor inputs.
And by crunching all that messy, unpredictable data.
Exactly. By processing all that nonlinear data, the models learn. They learn to predict task durations and optimize these incredibly complex variable operations like coordinating tug movements or streamlining container handling or managing the notoriously difficult berth scheduling.
And that focus on optimization. It isn't just about making one port a little bit better. It's a global necessity. It's driven by just fierce competition.
That's the geopolitical reality of it. We've seen this profound shift in global port dominance over the last decade or so.
It's been dramatic.
It has. If you look at the global top 10 maritime hubs, the data up to 2021 showed that, remarkably, only the Port of Rotterdam managed to hold on to its position.
Just one European port left in the top 10.
Just one. And that fact alone, it just underscores the rapid progress and, frankly, the sheer technological aggression shown by Asian ports, especially those in China.
So what's their secret?
Their increasing dominance is, well, it's inextricably linked to deep digital integration. They didn't just automate a few terminals. They integrated AI and digital tools into their entire operational and administrative systems, and they did it at a national scale.
A holistic approach.
A completely holistic adoption. It allows them to move containers faster, cheaper, and with a much higher degree of certainty. They are actively setting the pace for modernization that Western ports are now, frankly, scrambling to match.
And this isn't just about private companies competing, is it?
No, it's not just a technological race, it's a geopolitical one. It's driven by things like regulatory flexibility and huge, large-scale state investment that just allows for this rapid integrated deployment.
And the competitive pressure isn't letting up. I mean, the
Mhm.
size of the ships themselves is literally driving the technological requirement forward.
It is.
We're already looking toward the next generation of port infrastructure, what's being called the sixth generation port, or 6GP.
And the 6GP represents a staggering leap in scale. To put it into perspective for you, current mega vessels might carry around, say, 20,000 to 25,000 TEUs.
TEUs being 20-foot equivalent units, standard container size.
Correct. The 6GP is being designed to handle vessels carrying up to 50,000 TEUs.
50,000. That is a truly incomprehensible logistical challenge. I mean, to visualize that for a moment, 50,000 containers stacked end to end would stretch for over 300 miles.
It's staggering. It really is. And trying to manage that volume in a very constrained physical space requires container terminals that are completely end-to-end automated.
There's no other way.
There is no other way. This volume means you have an enormous number of simultaneous loading and unloading tasks that have to be executed under absolutely perfect scheduling. So this just confirms the whole premise. Without the analytical power and predictive capability of an AI backbone, developing these future-scale, fully automated 6GP terminals would be, well, it would just not be feasible.
Okay, so we've established that AI is the engine powering all this automation. But an engine needs a roadmap, right? It needs a way to test and visualize its complex plans without risking billions of dollars of real-world assets.
And that's where we move to our first critical pillar, simulation, through digital twins.
So what exactly is a digital twin, or a DT, in the context of maritime logistics? Is it just a fancy 3D model?
That's a common misconception. It's so much more than that. A digital twin is a dynamic, a living virtual replica of a physical asset or a process, or in the port's case, the entire complex ecosystem. Living. The key is that it uses a continuous stream of real-time data from IoT sensors out in the physical world. It uses that data to monitor, simulate, and predict performance inside the virtual environment. It's a perfect, always-on virtual mirror of reality.
And why are ports so uniquely suited for this? I mean, why do they need this technology more than, say, other industries? Why can't they just rely on traditional planning models?
Because ports are the absolute epitome of a complex system. They are comparable in their organizational and logistical density to, say, a smart city or even an entire global supply chain.
What makes them so complex?
It's the sheer number of independent actors. You have shipping lines, terminal operators, truck drivers, rail companies, customs agents, all interacting constantly, but often with their own competing priorities.
And the system is nonlinear, I assume.
Highly nonlinear. A small change in one area, say one delayed truck, can cascade into massive congestion hours later across the entire system.
We see that kind of link between the port and city infrastructure all the time.
We do, and the DT is specifically designed to manage that integration. A great example is the Port of Hamburg's Smart Bridge project.
Tell me about that.
They're using a digital twin approach to link the maintenance and operational status of their city infrastructure, specifically the critical bridges that feed the whole hinterland transport system directly into the port's logistics planning.
So the city knows not to close a bridge when 3 massive ships are due to unload.
Exactly. The DT ensures that necessary maintenance closures are scheduled when they will cause the absolute minimum logistical disruption. It optimizes that city and port interaction.
So to optimize these incredibly complex, interconnected systems, the DT has to fulfill 3 core requirements. Let's start with the first one, situational awareness.
Situational awareness, right. This demands total transparency and, crucially, data integrity. It means achieving a perfect virtual mirror of all critical port processes in real time.
So everything.
Everything. Tracking every single vessel as it's approaching, assessing the minute-by-minute operational status of every piece of equipment, every crane, every yard stacker, and monitoring the precise degree of congestion in the truck queue or on the connecting rail networks.
And having that unified view is key.
It's vital. This high-fidelity data visualization promotes what we call intercompany awareness. It allows the shipping lines and the terminal operators to see the exact same undisputed truth about what's happening on the ground.
Which leads us directly into the second requirement, intelligent decision-making. This is where the DT stops just describing what's happening and starts prescribing what to do next, and that's powered by AI.
Exactly. The DT environment allows for proactive rather than reactive management. We can run millions of what-if scenarios, allowing the AI to test and optimize different strategies before a single physical resource is even committed.
So we're talking about solving terminal problems that are, well, they're famously intractable for humans to solve on the fly.
Computationally intractable, yes. Let's get into the specifics of those problems.
Please do. What are the technical challenges that really justify using an AI-enabled DT?
We're looking at what computer scientists call NP-hard problems. These are problems where the number of possible solutions just explodes exponentially as the scale gets bigger.
And a port is all about scale.
All about it. So
Yeah.
two key areas are in seaside operations. First, you have the berth allocation problem, the BAP, deciding precisely where and when a vessel should dock for maximum efficiency.
Seems simple, but it's not.
It's incredibly complex. Then you have the quay crane scheduling problem, or QCSP. This is optimizing the sequence, allocation, and distribution of all the loading and unloading tasks among the available cranes.
And a modern megaship might have, what, 5 or 6 cranes working on it at once?
Easily. So the number of possible sequencing variables becomes astronomical. The AI uses the DT to solve these problems by prioritizing tasks based on real-time factors like sudden weather changes, the risk of equipment downtime, and container destination priority.
So without the AI solving these NP-hard problems inside that simulated DT world, human planners would literally just be guessing.
They'd be guessing, or they'd be relying on these heavily generalized rules of thumb that just break down under real-world pressure.
Right.
And we see this predictive power also revolutionizing yard operations.
How so?
Well, the DT enables predictive stacking and storage of containers. Instead of just stacking containers based on when they arrived, the AI predicts when they will leave and by what method, truck or rail.
Ah, so it's thinking ahead.
It's thinking 3, 4, 5 steps ahead. The goal is proactive placement to make sure that the container destined for the next train out is easily accessible. You want to avoid all that costly, time-consuming reshuffling and congestion later on.
And crucially, this predictive foresight extends to the equipment itself, I imagine.
It does. That's a third key area of application for intelligent decision-making: maintenance. The DT is constantly drawing on real-time data from vibration sensors, load monitors, historical failure rates.
All the vital signs of the machinery.
All of them. And it seamlessly integrates predictive maintenance. It can assess the trade-off between running a crane at maximum utilization right now versus the probability of a catastrophic failure in 3 days.
And it lets the port schedule maintenance windows when it's least disruptive.
Precisely. It prevents that cascading failure we talked about earlier.
Do we have any hard numbers on the impact of this predictive power?
We do. In one specific application domain that was focused on using AI-enabled digital twins for predicting mechanical failure, the implementation led to a verifiable 22% reduction in downtime.
22%. That's a staggering number.
It's critical because every hour of downtime for a single crane can cost tens of thousands of dollars in delayed vessels and lost productivity.
Okay, so a 22% reduction is huge. But if the DT is preventing downtime, that information, the prediction that a crane is about to fail, it has to be shared across multiple companies, right? It can't just stay inside the terminal operator's little silo.
Exactly. And that brings us to the third core requirement for the DT, which is multi-stakeholder governance and collaboration.
Everyone needs to be on the same page.
Everyone. A modern port involves dozens of independent actors. The DT acts as the unifying interface, promoting coordinated actions among terminal operators, shipping agents, railway companies, government agencies, you name it.
Like with the port call.
Take the complex sequence of the port call. That involves the port authority, the pilots, the tugs, the moorers, the cargo handlers. The DT enhances that coordination by providing a single, trusted version of events and predictions to streamline the entire sequence. It just makes the whole process smoother, safer, and faster for everyone.
All right, this shift towards hyperautomation and digital twins is clearly delivering monumental efficiency. But it forces us to confront a really fundamental human and, frankly, legal problem: control and liability.
Yes.
When you have digitization drastically reducing human intervention, you create what our sources call a massive digital trust deficit.
That's a great term for it.
The different actors, they feel like they no longer have direct oversight, and they absolutely demand reassurance about legal liability when things inevitably go wrong under the direction of some automated digital device.
And that trust deficit is the crucial lock that prevents full-scale global deployment, especially in cross-border trade where you have different legal jurisdictions intersecting.
So what's the key?
Well, that is why our second pillar, blockchain, is so indispensable. If digital twins provide the simulation and the visibility of the truth,
Then blockchain validates it.
blockchain provides the secure, immutable trust protocol that validates that truth. It's a decentralized, tamper-proof ledger that's designed to secure information flows and financial transactions.
So how does this, fairly obscure technology actually translate into trust for, say, a shipping line?
Well, it addresses the need for accountability and integrity on a few different fronts. First, it ensures you have legally validated digital devices and records if there's a dispute.
For example,
If an automated crane drops a container, the blockchain record can anchor the exact sensor data and the automated instruction at that precise moment. It gives you irrefutable legal proof you can take to court.
okay, that's huge. What else?
Second, it helps with the dematerialization and elimination of all those cumbersome paper documents, bills of lading, certificates of origin, signed commitments.
Paper trail that clogs everything up?
It's one of the biggest bottlenecks in traditional global trade. Blockchain replaces them with smart contracts and digital ledgers, which drastically improves the fluidity of logistics flows.
And the third point,
The third, and this is perhaps the most valuable for compliance, is that it provides end-to-end traceability and legal proof of responsibility for goods during any transport incidents. This immutability is just essential for auditability, especially for high-value or sensitive cargo.
are these concepts actually moving from pilots into real industrial use? Or is it still mostly theoretical?
We're seeing rapid deployment. Now, while public blockchains like Bitcoin, they face barriers, the permissioned private consortium blockchains are actually ideal for logistics.
And we're seeing platforms emerge.
Yes, platforms like Scootchain, Provenance, Chain of Things, and Wave are being actively deployed right now.
Can you walk us through a specific example of Port Authority actually integrating this?
Certainly. Let's look at the simulator that was developed in collaboration with Europa Port for the Port of Le Havre. This was a proof of concept, but it was focused entirely on certifying data integrity for high-risk goods.
And you mentioned they were using a private Ethereum network. How are they using this idea of notarization?
Right, so they chose a private Ethereum network, which means it's a permission system where only verified participants can operate the nodes to certify the traceability of sensitive containers.
Like what? Dangerous materials.
Exactly, containers transporting dangerous or controlled materials. So each critical event in that container's journey, its arrival, its inspection, the sealing, customs clearance, is anchored or notarized onto the blockchain.
So it's like a digital, unchangeable stamp.
That's the perfect way to put it. It serves as a legal, unalterable certification of that information. For example, an operator, let's call him Charlie, can consult the blockchain and instantly verify the exact sequence of security operations or consult the container's history. It eliminates any possibility of someone trying to manipulate the logs after the fact.
That seems absolutely critical for managing high-risk scenarios. I'm thinking of things like ensuring regulatory compliance for highly sensitive logistics like food provenance, or the specific requirements of, say, the halal supply chain where origin and processing integrity are just paramount.
Precisely. Blockchain's immutability provides the foundation you need to ensure product authenticity and regulatory compliance from the farm to the fork, or from the factory to the end user.
But despite this clear benefit, we have to acknowledge the obstacles that are preventing huge, large-scale deployment today.
We do. There are still friction points.
What are they? What's still holding back global integration?
Well, complexity is still a bit of a barrier to adoption, but the two critical issues are throughput and energy cost.
The classic blockchain problems.
Exactly. For public blockchains that rely on proof of work, the energy consumption is immense, and the transaction rates are just far too low for the millions of transactions a global logistics system requires. A system that can only process 10 transactions per second cannot manage the world's trade.
So the solution for maritime logistics has to be moving away from those public energy-intensive chains toward more specialized high-throughput systems.
That is the path of industrial reality. They have to rely on permissions networks, things like Hyperledger Fabric or these specialized private Ethereum networks, which drastically lower the energy costs and boost the transaction rates.
But even with those solutions,
Even with those, you still need significant harmonization and standardization across competing multinational companies. The technical solution exists, but the institutional cooperation, that's still catching up.
okay, here's where it gets really interesting for me. The confluence of these two pillars.
The synergy.
Yes. We have simulation and prediction through digital twins and AI on one hand, and we have immutable accountability and trust through blockchain on the other. Logically, they can't live up to their full potential in isolation, can they?
No, the synergy is fundamental to the entire concept of a smart port. I mean, think about it. The AI algorithms, which are the brain of the digital twin, they rely entirely on high-quality, reliable data to function
It's
effectively
to predict accurately.
and to make autonomous decisions. If the input data is corrupted or it's unverifiable, the AI's prediction is, well, it's useless, or, even worse, it could be catastrophically misleading.
So blockchain is the guarantor.
Blockchain provides the secure, tamper-proof record you need to certify the reliability and the integrity of that data source.
So let me see if I have this right. Blockchain validates the integrity of the input data, which allows the digital twin environment to trust the simulation results,
Yeah.
which in turn allows the AI to trust the data it's using for training and prediction.
Yes.
This establishes what you could call intelligent trust.
That's the perfect term for it. And this integration is probably best visualized using the theoretical model our sources describe, the blockchain-enabled digital supply chain, the BDSC framework.
Okay, let's break down the functional architecture of BDSC. What are the moving parts?
It integrates three core technological elements. First, you have the IoT sensors. These are the eyes and ears of the system. They provide the real-time monitoring of every physical attribute of the goods, their location, temperature, humidity, vibration, all of the logistical events.
And then comes the blockchain.
Second, the blockchain immediately records all that IoT data immutably. That ensures its integrity and provides verifiability. And then third, you have the AI and the smart contracts, which leverage this now verified data.
And they're the action layer.
They're the action layer. They automate compliance checks. They release payments only when conditions are certified as met. They automatically mitigate risk based on certified deviations. And they manage the incredible complexity of the DT simulation.
So how does this intelligent trust translate into, quantifiable operational improvements? Give us a concrete example in vessel movement.
The biggest improvement is maximized certainty. AI algorithms can integrate this real-time certified data from blockchain databases and IoT sensors to track a vessel's entire trade route.
And because the data is verified?
Because the data, the weather reports, previous port call durations, fuel burn rates, is verified, the AI can calculate an extremely accurate expected time of arrival, or ETA, far beyond what traditional scheduling tools can do.
And an accurate ETA means the port can reduce that really expensive and environmentally damaging practice of ships just having to wait offshore.
Precisely. By maximizing the certainty of the ETA and the subsequent estimated time of departure, or ETD, the port can maximize the efficiency of the berthing time, minimize congestion in the bay, and cut down the environmental impact of ships just idling while they wait for a berth to free up.
It must also enable proactive risk mitigation for sensitive cargo, too.
Oh, that is a key resilience benefit. If a temperature deviation for perishable goods occurs, say, an IoT sensor inside a refrigerated container detects the temperature rising above the acceptable threshold.
An alert goes out.
An automatic alert is immediately triggered, and that alert, plus any subsequent corrective actions that are taken, like changing the generator unit, are instantly recorded on the blockchain.
So there's a permanent record.
A permanent, unchangeable record. This integration strengthens operational continuity and ensures end-to-end traceability and accountability in case of spoilage or a legal dispute. This fusion of foresight from the DT and integrity from the blockchain, it's truly the intelligent backbone for the next generation of global trade.
Now, though, we have to turn our attention to the necessary friction. The deployment of these complex, powerful, integrated technologies. Yes, it delivers monumental efficiency, but it also forces these immediate, non-negotiable decisions about labor, workforce adaptation, and security exposure.
This is where the theory collides with industrial reality.
So let's start with the first one, efficiency versus labor concerns.
Okay. The pure economic argument for efficiency is, well, it's irrefutable. Smart ports are defined by operations running 204/7 with minimal or no human intervention.
That's the selling point.
It is. This degree of automation, from autonomous tugs and cranes to predictive scheduling software, it significantly reduces the reliance on manual labor, which directly impacts operation costs. And that is the primary attraction for investors.
But if AI is automating tug operations, and it's optimizing cargo handling and managing the schedule of every single movement in the port, what is the fate of the existing, highly skilled, and often unionized workforce?
That is the critical socioeconomic tension that port authorities have to manage. And it is a massive oversight to focus only on replacement.
It's more complicated than that.
Much more. The transition necessitates a fundamental overhaul of the entire workforce structure. We need to implement extensive training initiatives and focus on modifying workers' skill levels. The whole narrative has to shift from replacement to reskilling.
Our sources cite a really crucial alternative model here, the Workport project. Tell us about the philosophy behind that.
Right. The Workport project, which has roots going back to the year 2000, is explicitly described as anthropocentric,
Human-centered.
human-centered. This model runs completely counter to the pure automation model. Instead of seeing workers as a cost center to be minimized, it emphasizes the human side of organizational success. It argues that true resilience comes from maximizing human adaptability.
So instead of being replaced, workers are moved from the physical labor on the key to the, cognitive labor in the control cockpit.
Exactly. This requires multi-skilled team members who are trained in data analysis, in robotics maintenance, system oversight. It promotes decision-making autonomy for these highly skilled members and actively enhances the organizational culture.
So you're moving from being a longshoreman to a data analyst, or from a tug driver to a remote robotics technician.
That's the transition, but it demands an enormous investment in education and training to ensure the workforce actually evolves alongside the technology.
That sounds like a brilliant and ethical and, frankly, necessary approach. But we have to confront the financial friction here. Does the investment in automation always pay off immediately? Does it justify the massive capital expenditure?
And that's the challenge. We have to be honest about the return on investment. Some analysis, and this was citing 2018 data, found that the immense upfront capital costs for full port automation could, in fact, potentially outweigh the short to medium-term operational benefits.
So it's not a magic bullet for cost savings.
Not right away. This highlights a critical point. Automation isn't just a quick cost-saving measure. It is a long-term strategic investment required to get to that 6GP scale. And you have to accept that the ROI might take many years to materialize. Authorities have to manage union negotiations and training costs while accepting a long and potentially risky path to profitability.
Okay, so if the first trade-off is between technology and people, the second one is between hyper-efficiency and, existential security risk.
A big one.
By connecting every crane, every vessel, every ledger, and every sensor to gain speed, we inherently create a huge interconnected attack surface.
The risk exposure is massive, and it's immediate. We're building these pervasive environments that rely heavily on wireless sensors, pervasive IoT networks, public cloud computing platforms, and the massive data aggregation required by digital twins.
And all those connections are potential vulnerabilities.
Every single one. These highly integrated systems make the entire global supply chain susceptible to data breaches, to sophisticated state-sponsored hacking attempts, and third-party vulnerabilities through API connections.
And the digital twin itself.
Yeah.
That seems like a particularly juicy target.
Right.
It's the single point where all of the port's operational intelligence lives.
It is the ultimate target. DTs rely on data aggregation from dozens of sources, ERP systems, Vethel manifest data, customs clearance systems, external logistics providers.
All the secret sauce.
All of it.
Yeah.
And because this data is shared and typically cloud-based to enable that multi-stakeholder access, the DT becomes a nexus of highly sensitive business information. A breach here could compromise not just the port's operations, but the logistics strategies and customer data of every major shipping line and trade partner.
So protecting this shared aggregated data demands.
Well, it demands mandatory and robust technological countermeasures.
It does. And the solution to the risk has to also be technological. You're essentially fighting AI with better AI.
How does that work? The same technology that's driving the automation has to be leveraged to enhance security. AI can analyze network traffic at speeds impossible for humans. It can refine cryptographic methods, bolster anomaly detection within the network, and help identify and prevent sophisticated threats in real time. We are talking about implementing zero-trust security models across the entire smart port infrastructure.
Define what a zero-trust model means in a port environment.
It means that no user, no device, no system, whether it's inside or outside the network perimeter, is trusted by default.
Trust no one.
Trust no one. Every single transaction, every data request, every communication has to be verified before access is granted. Strong measures like end-to-end encryption protocols and mandatory multi-factor authentication are no longer optional best practices. They are mandatory requirements to protect the highly sensitive business and national security data flowing through these networks.
The stakes are just too high.
The stakes are too high to rely on perimeter defenses alone. Smart ports are vital infrastructure. They're critical for national security, for economic growth, for social development. Any disruption means you need strong protective measures to ensure safe, continuous operations in a world where cyber warfare is increasingly targeting infrastructure.
So what does this all mean for you? Our deep dive confirms that smart ports have moved decisively from theoretical concepts to industrial reality here in 2025.
They're here to stay.
And this transition is built entirely on that essential technological fusion we've been talking about. Digital twins, which provide the foresight, the simulation, the holistic optimization.
And blockchain, which provides the immutable accountability, the integrity, and the trust that you need for secure, multi-stakeholder transactions.
Indeed. The development of these truly next-generation automated ports, the ones pushing toward that sixth-generation scale, would be entirely infeasible without the analytical prowess and predictive certainty that AI provides.
But as we've really emphasized, this pursuit of hyper-efficiency forces us to confront these fundamental trade-offs. Right. The nonstop management of significant cybersecurity risks in this interconnected environment, and the ethical, the economic requirement to proactively address the massive labor skill shift that automation demands.
The ultimate success of this trillion-dollar digital transformation, it rests not just on the processing power of the AI or the immutability of the blockchain, but on the ability of port systems globally to manage that human and that digital friction responsibly and strategically.
And that leads to the final provocative thought for you to explore as you consider the future of global trade.
That's it.
Given the significant investment and complexity required to deploy these intelligent systems, how should port authorities, right now, balance the relentless drive for sixth-generation port automation with its immense capacity for handling those 50,000 TEU megaships against the equally vital need to invest in human capital? How do they balance that against modifying skill sets and implementing training initiatives to ensure we have